All right, folks, welcome back. It feels like it's been no time at all since I last saw you, but this year. So hopefully everybody had a good time. Did anybody do anything they'd like to share or learn anything or not do something that they wanted to do? I'll go first. I went home to Chicago for 6 days and had a great time. Saw my grandparents for the first time in a minute. Hung out with my twin sister. And yeah, it was just nice to get away. It was my first time traveling in a while, so it was good. And then I came back to Charlotte and just hung out. So I feel a little bit rested, but at the same time, feel like I could have definitely used another week. Maybe you all feel differently. Good. That's beautiful. It's a perfect time. And that's actually a good segue into what I was going to talk about, which is the season of spring. Of course, it represents new growth. It represents rejuvenation and replenishment. And for me, it's an opportunity to think about, and I think also because my birthday is in a few days. So it's also a great opportunity to think about what I want to be true for this next phase or this next stage of life. And I want you guys to think about that as well. You know, I like to come in on Mondays with a message of positivity. This Monday feels a little special because it's the first Monday after spring break. It's the first Monday that we've been in school in the month of April. And it kind of feels like we're really headed into that final stretch of school, which I'll talk about. Thank you, and I agree that it is special. Maybe is this your birthday month as well? So this quote says, "Spring is a lovely reminder." Today is your birthday? See, Power School wasn't working for me. Well, excellent, Anna. Happy birthday. And maybe we can have some people send some nice messages to you in the chat. I hope you're having a wonderful day. It's a beautiful day outside from what I understand, and it's only getting better. So hopefully you get some time to be outside and enjoy some family time as well. But we are certainly blessed to have you in this class, and I hope you enter this next year of life feeling only positive feelings. But like I said, I like to start off the message or the week on Mondays with messages of positivity and just remind you all that there is and always will be an opportunity for you to think about what you want to be true and what goals you're hoping to accomplish. So this Monday, hopefully you can take some time to do that because we are really headed into that final stretch. This season, spring, is a lovely reminder of how beautiful change can truly be. And some of us need to come to terms with the fact that some of our habits do need to change as we head into this last part of the school year. So we've got 3 units left and 10 standards left, including this unit. So 8, 9, and 10. And then in this 8th unit that we'll begin today, we'll cover 5 standards. It sounds like a lot, but really we're going to get through the first 2 today. Excuse me. We've got 35 days of school left. Really like 34 and a half because you guys are basically done with today. And we've got 30 days of school before finals begin. So it's not a lot of time. In this class, the final will be on May 26th. And of course, it'll be 65 questions. 5 of those questions are kind of what we consider test items. So the state is just kind of putting them out there to kind of grasp what biology teachers are focusing on. Those don't count towards your final grade. So 60 of the 65 questions are an important indicator of your final grade because that EOC exam represents 20% of your overall grade. So something that we need to take seriously. I'm really, really confident in this class, probably more confident than I've been in one of my biology classes in a long time, but we do still have work to do. We still have some learning to do, and then we're going to dedicate almost 2 weeks to reviewing previous material, which I think will be helpful to a lot of you. But I believe in each of you and your individual potential. I believe in our collective potential. And I really do think that we should be 4s and 5s in this class on the EOC. I don't really anticipate or expect that anyone will be below 4. And I think that's the expectation we should all set because that's what we deserve. That's where we're headed. All right, so this 8th unit is going to focus on evolution. I think it will lend itself to some interesting conversations, and we're going to watch some videos that maybe you all we'll introduce you all to some new concepts and some new histories. But it's important for me to note at the beginning of evolution, or at the beginning of a discussion about evolution, that evolution is just a theory. Now, I say just, I use the word just, but it's a strong theory. It's a theory that is supported by a lot of evidence. Some people, because of their religious beliefs, struggle with this idea of evolution, or don't believe that it's true. And, it's not for me to say what you all should believe. You're young adults. You should be able to consider facts. You should be able to think about evidence, and you should be able to come to a logical conclusion once you do that. So I'm not going to be here to tell you what you should believe. I'm just going to give you the information that we do know to be true, that has been collected by scientists in different fields over the course of many hundreds of years. Not many, really just the last 200 years or so. And then we'll talk about how those pieces of evidence contributes to this theory of evolution. So that's really the first standard. Students will explain how fossil, biochemical, and anatomical evidence support this theory of evolution. You don't need to write this down. I'm just introducing the standards for the unit. But, like I said, evolution does lend itself to some interesting conversations that kind of get into the ethics, that get into some interesting history as well. At the same time, more so than most other fields of biology, I think evolution is past facing, but we can have conversations about looking ahead too, and what lessons we can learn from the fossil record, what lessons we can take from chemical and biochemical analysis from evolution, and we'll talk about that as well. The next standard is natural selection. We're going to talk about this as a concept, so you all will be able to explain how natural selection influences the changes in species over time. Natural selection is a pretty simple concept, and it's basically this: survival of the fittest, right? You raise your hand if you've heard of survival of the fittest. Okay, several of us have. It's important, and we'll talk more about this. Survival of the fittest does not mean the person who, or the individual who can lift the most weights, who can run the fastest. What we mean when we say fittest is who is going to be the best at reproducing. Which individuals within a population are going to have the most offspring, because those individuals are the people who are not necessarily people, but those are the individuals who will contribute most to the gene pool. So if we were the only people who existed on Earth and I had 20 kids, whereas you all each had 2, I'm contributing a lot more to the overall gene pool in this room because I'm passing on my genes to my children. So in that case, I would be considered the fittest individual. Now, some of my traits are going to be some type of advantage. Maybe there's a reason that I was able to have 20 and you all were only able to have 2. I had some type of advantage. And so that's what natural selection is getting at. The individuals that have the advantages are able to survive longer, which means they are able to have more children, which means that they contribute more to the gene pool. That's natural selection. We're also going to have good conversations, relevant conversations about diseases, specifically bacteria, viruses, and other toxins. And of course, this is a relevant conversation because we now find ourselves a year and some time into a pandemic, but we are seeing the light at the end of the tunnel. Has anybody been vaccinated yet? Fortunately, I did get my second shot just before spring break. So I'm feeling a little better. My family has been vaccinated, so I feel good about that. And I'm looking forward to the young people being vaccinated as well, so you all can start to feel more comfortable living more normal lives. But we'll talk about the specifics of the coronavirus, what has made it so dangerous. And also we'll talk about the science behind the vaccines. What I'm hearing from some of my other students who were here this morning is that they're skeptical about the vaccine. And I think there's reason to be skeptical, but at the same time, there's more reason in my mind to be comfortable with it and to be excited about it. So we'll talk about some of the science. That way you guys can, again, come to your own conclusions. And then these last 2 standards we're going to go ahead and knock out today. They're very simple. We'll talk about classification systems, and we'll talk about classification models. All right, so let's go ahead and jump into it. Today's April 12th, 2021. For my people who are here in person, I did pass you some guided notes that are going to follow basically exactly what you all see on the screen today. Yes, Ashanti. A pencil. Yes. Give me 1 second. Um, you can feel free to use those. You don't have to. I just would like to see everybody taking notes. I know some of you take notes virtually. That's fine. But if you don't have a notebook or if you would prefer to use these guided notes, they are available to you. Yeah. All right, so the standard we'll work on today is to explain the historical development and changing nature of classification systems. We've got three essential questions. What is the classification system? Or what are, I guess I should say. What benefits do they provide? And how have they changed over time? Just giving folks an opportunity to write down some of this intro info. JT, I didn't see your message, but did you have a good time in New Orleans? Good. That is a very fun city. Okay. All right, so scientists use an 8-level system to organize all organisms based on common characteristics and evolutionary relationships. Now, Stelly, you're talking about potentially another classification system that we don't really mention in this class so much, but they do exist, where we would classify individuals within a population based on their fitness. Here, we're talking about different species. So not individuals within one population, but actually different species. Of course, there are and have been billions of species of living organisms on the planet Earth. Vast majority of them are extinct and have been extinct for a long time. But it's helpful to scientists of various fields, molecular biology, biochemists, evolutionary biologists, to be able to classify organisms based on their similarities. Oftentimes, the more similarities two species have, the more closely related they are. And when we say that, we're not talking about cousins. We're saying that they have a common ancestor that may have only existed 50,000 years ago. Sounds like a long time, but in the grand scheme of things, it's not a long time at all. So in this image on the right, we can see this classification system, this 8-level system. Way in the top right, we see the word domain. Domain is the most general classification. And so in this case, the domain we're looking at is eukarya. And we see all eukaryotic life forms are included in this domain. What does it mean to be eukaryotic? Does anybody remember that? Yeah, excellent. So eukaryotic organisms have nuclei in their cells. They have a nucleus. So this domain, excuse me, has all of the living organisms on planet Earth, all of the living species on the planet that have nuclei inside of their cells. But of course, that's not super helpful to us if we are trying to talk about a specific group of species or even one species. We might want to be more specific than just domain. So we can get more specific and talk about the kingdom Animalia. So when we do that, now we're excluding specific types of life forms like fungi and plants. They have their own kingdoms. So the kingdom Animalia is only going to be focused on a specific subset of organisms, of species. But we might want to be more specific than that. So we can talk about the phylum Chordata. And if you look at that phylum, you see that we've excluded, in this case, insects. We've also excluded sponges and coral. Of course, those are considered animals, believe it or not, but they don't fit into the phylum Chordata. We might want to be more specific than that. We can talk about the class Mammalia. And so we exclude fish, we exclude reptiles, we exclude, what else am I missing? Amphibians. We might want to be more specific than that. We can talk about the order Carnivora. Of course, these are your carnivores. So you can see we've excluded in that case, it looks like dolphins and zebras. All right, but you see we can get more and more specific. So the 8 levels of classification, I'm actually going to come back to this slide, are this. Starting with domain as the most general and getting more specific, these are the 8 levels of classification: domain, kingdom, phylum, class, order, family, genus, species. Okay. Now there's a mnemonic device. You can see it behind me on the whiteboard that has been taught for generations, I'm sure. Mnemonic devices are just really helpful ways to remember things because you make an acronym or you can make a sentence to represent specific words. This is the one that I think most biology teachers use. Do keep pond clean or Froggy gets sick. Of course, each of the first letters of those words corresponds to one of the levels of classification. So that's how I've always remembered the order that they're in. And it might be helpful to you. You can also come up with your own mnemonic device, your own sentence as well, whatever could be helpful to you. I remember a couple of years ago, students had some, I don't remember the first 4 words, but I know that the OFGS stood for or fight get started. So not sure where they went with that one, but or where they got it from, but it worked for them. So mnemonic devices are really helpful study skills to have. Questions? No, it looks like everybody. And I would include in your notes that, of course, domain is the most general and species is the most specific. Just make sure you have some indication of that because these are not randomly ordered. All right. Oh, I did say I was going to go back. So this is pretty intuitive, but the classification systems have changed over the years. 270 years ago, when scientists first became interested in classifying the organisms, we knew very little about how we could start with that process. In fact, things were simply classified as plant or animal. As technology improved, we had many more ways of understanding some of the nuances between species. We figured out that even on a cellular level, species that might appear to be exactly alike are actually different. And so this gave us new ways of looking and classifying the species. We can think about the fact that the microscope is a relatively recent scientific advancement. So for a vast majority of human history, we had no way of knowing that microscopic organisms existed. So it really wasn't until the middle of the 19th century when we could actually start to think about bacteria and other microorganisms. Okay, so again, as the technology has improved, we can do a lot more with the classification. Now we can even look at the DNA of species and be able to say that, again, two species that might be anatomically exactly alike are actually different on a nucleotide level, and so they get classified as different species. Okay, there are two ways that we can name organisms. The full classification is not common because it's pretty cumbersome. Nobody wants to use all 8 levels or have to remember all 8 levels. So the easier way is just to use the scientific name, which just includes the genus and the species. This is also known as binomial nomenclature because it just uses the first two words. All right. All right, so binomial nomenclature simply uses the genus and the species. Now, there is a specific way of writing it. When you're typing, you should always italicize both words, meaning you write it in its slanted font. When you're writing it by hand, you should always underline it. The reasons for this, I don't know. Some white man probably made it up 200 or 300 years ago. But this is just how we do things. The genus is always capitalized. Okay, so in this example, the H in Homo should always be capitalized. The species is never capitalized. So sapien, the S is lowercase. All right, so that's just kind of the nomenclature. That's just how we name things. All right, so we can see that if we were to use the full classification again, it would be pretty cumbersome, kind of annoying. Nobody wants to remember all 8. It might even be difficult to remember all 8 for every single species. So stick with the scientific name. How many of you knew that there were at one point different species of humans? Did you guys know that? Yeah, there were. So 40,000 years ago, when modern humans were first leaving the continent of Africa, there were not just Homo sapiens, there were also Neanderthals. You guys have heard of Neanderthals, I'm sure. And there were also what were called Denisovans. So there were at one point up to a dozen, what we know of now through the fossil record, up to a dozen different species of humans. We're still trying to fully understand why it is that Homo sapiens are the only surviving species. We think it probably has something to do with our brain, the general size of our brain. It's a relatively large and relatively fatty brain compared to the rest of our body. And so we probably developed some communication skills that other species of humans didn't have, We also probably just got lucky because, you know, the Earth has gone through several different ice ages in the last 50,000 years, and we probably just happened to be in the right place at the right time. Some people who have European ancestry actually have remnants of Neanderthal DNA in their own cells. Their own nuclei have some Neanderthal DNA. Now, this does not mean that they are subhuman. It doesn't mean that they are not human. It just means that they have some common ancestors who were Neanderthals. So because of that, we know that Homo sapiens and Neanderthals at one point lived close enough to actually mate. So they may have been living in community with one another. But for whatever reason, the Neanderthals became extinct. The Denisovans became extinct. Like I said, there are up to, I think there are like 12 different species. We happen to be the only ones who remain today. Okay. So we can apply these classification systems to using what are called dichotomous keys and phylogenetic trees, also known as cladograms. Dichotomous keys are pretty easy to use. So they're called dichotomous. Di, of course, means two. Dichotomous is a word that just means kind of this thing or it's this thing. There's no in between. So a dichotomous key puts a set of two statements together, and you've got to answer the statements. You've got to say, yes, it's this, or yes, it's this. It can't be both. It's got to be one or the other. And then based on the statement that you choose, you're either going to be told to go to another set of statements, or you're going to be given the species. You'll be given the information that you're looking for. You always start with the first set of statements. You might be told to jump around after that, but you should always start with the first set. All right, so we're seeing this image of a species. We're going to act like we don't know what that species is, really. I'm sure most of you probably have an idea of what it is, but we're looking for the scientific name. So we start with the very first set of statements. That very first set says solid coat or not solid coat. So what are we looking at? Does this organism have a solid coat or a not solid coat? Not solid coat. Thank you. And so what does it tell us to do once we identify that this is an organism with a not solid coat? What does the dichotomous key tell us to do? Go to 3. Yeah. So we're looking at this statement, not solid coat. We're going to jump down to the third set of statements. Skip the second one. It's not helpful to us right now. The third set of statements says stripped, but that should say striped, I assume. Striped or spotted. So what are we looking at? Is this organism striped or spotted? Thank you, Sally. With this information, we can figure out what the organism is. We get the scientific name. Don't know how to pronounce it, but there it is. Commonly known as a cheetah. So we've got the genus, we've got the species. All right, let's try another. Different organism here. We're going to start off with the first set of statements. So does it have a solid coat or a not solid coat? This time it is a solid coat. So with that information, what do? We go to 2. This time we're not paying attention to 3, so we just jump directly down to 2. 2 says smooth coat, long tail, no mane, or smooth coat with a mane. So which one are we looking at, A or B? We're looking at A, and in this case, A tells us we're looking at Felis concolor. Not sure if that was supposed to be in Spanish, but it could be a Spanish phrase. All right, so commonly known as the cougar. So dichotomous trees, pretty simple, pretty easy to use. Phylogenetic trees are much more common. Their utility is much more important. You'll see them actually used. I've never really seen a dichotomous tree used in like real research, but phylogenetic trees, of course, are used. And they work very similar to those pedigrees that we talked about in the last unit when we were talking about genetics. The closer the organisms are, closer the two species are, the more closely related they are. Same thing with the pedigrees, right? Where the lines intersect is going to show common ancestry. And in general, you always move up. So we're moving in. Okay, so again, where the lines intersect shows common ancestry. In this case, we can see the common ancestor of species 1 and 2 is much more evolutionarily young than the common ancestor of species 1, 2, and 3. Okay, so we've got to imagine that these are a timeline, basically. They're communicating time to us. Not specifically in years, although we probably could add years, but just kind of relative time. Okay. So for example, we've got another phylogenetic tree here. Again, the closer two species are, the more closely related those two species are. So it's kind of easier to start with the least closely related. So which two species in this example are the least closely related? If they are not closely related, then they should not be close to one another. So which two are the least closely related? Yeah, the shark and the bird. Good. They're just so far away on the phylogenetic tree that it's obvious they don't have a common ancestor that existed recently. Their common ancestor existed a long time ago. And we can see that in the tree as well. All right, believe it or not, that's all I wanted to talk about today. So there is an exit ticket, of course, and there are two asynchronous assignments. The flip and flop practice may not work because it's going to force you to make a copy of a Google document, and Google has been uncooperative today. So at the very least, you should have plenty of time to get the classification practice done, as well as the exit ticket. This unit is going to take us 7 days of class. So all of the assignments will be due on Tuesday, April 20th. Paris, that's good to know. I typically just give people until the end of the unit to submit things without marking it as late. Just gives you a little bit more time, especially because of our virtual settings. So Tuesday, April 20th is when I would expect all of these assignments are due. I think I upgraded your Power Schools before your grades before spring break, so you all can check that out too and see where you stand. I think I still have to do Unit 7 for this class, but I'll take care of that today. So yeah, use your time wisely. We've got 30 minutes, right? Yep, exactly 30 minutes. Should be plenty of time to get, hopefully the flip and flop practice does work, but if not, then plenty of time to get the classification practice and the exit ticket done. See you guys, folks at home. Enjoy your day.